Okay, so like, have you ever seen one of those like crazy realistic AI generated videos? You know, the ones that are like a minute long, super high quality, and you're just like, wow, AI is getting really good. But then you start to think about like, how would you use this to create something longer? You know, a video with multiple shots, all kind of flowing together to tell a story, like a scene in a movie. Suddenly that single shot magic feels, well, a bit limited.
Yeah, yeah, totally. It's true. Those short clips are impressive, right? But real visual storytelling, it's all about how those individual moments like connect and build upon each other. You need multiple viewpoints, different perspectives. That's where the real challenge comes in, trying to get that seamless visual and dynamic continuity in, longer sequences with a bunch of different shots.
Right. It's that jump from making a cool little snippet to actually crafting a whole narrative.
Exactly.
Well, lucky for us, there's some really cool research that we're going to dig into today. It's called long context tuning, LCT for short. And essentially, it's this brand new training method that's trying to teach those uh, already impressive single shot video AI models how to create these consistent multi-shot scenes. Like they're already good at generating these isolated moments, but now we're trying to give them that understanding of scene structure. Like almost like they can think, okay, this shot needs to connect to this shot, and this is how we maintain visual flow.
Yeah, it's like we're trying to upgrade their brains a bit, give them the tools to think beyond just individual moving pictures.
Exactly. So for this deep dive, we're going to be looking at this academic paper. It's called Long Context Tuning for Video Generation. Really get into the nitty-gritty of it. See what's so academically interesting, what's new here. What are the core, like, scientific advancements that make LCT so exciting?
Totally. Because we're not talking about just like a small tweak here. This is a pretty fundamental shift in how these AI models are learning to process and generate videos. Like they're actually starting to understand the concept of scene level coherence.
And that's what we want to unpack. Like, what makes this approach stand out? Why is this a big deal scientifically?
For sure.
But I think to really appreciate what LCT is doing, we need to like take a step back and understand why creating these consistent multi-shot videos has been such a challenge for AI, historically. You talked about continuity. So technically speaking, what are the specific aspects that make it so hard to get right at the scene level?
Well, at the core of it, it comes down to this idea of scene level coherence. And there's two main parts to that. First, there's, visual coherence. Like think about a character in one shot. Now, in the next shot, their appearance, it needs to be consistent, right? Their clothes, their hair, even just like subtle things about their face and the background too. The lighting, the colors, everything needs to have that same unified feel across all the shots in the scene. If you have all these jarring jumps and changes, it just breaks the viewer's immersion.
Totally. It's like the visual consistency keeps you grounded in the story, right? Makes it feel real.
Exactly.
And what's the second part, the second challenge to this whole coherence thing?
Right. So the second part is temporal coherence. And this is all about the consistency of motion and timing. Like if a character starts doing something in one shot, then the next shot has to pick up on that action naturally. It needs to feel continuous. Same thing with camera movements. You can't just go from a smooth pan to a sudden close up without a reason. Narratively speaking, it needs to flow.
So we're talking about maintaining that visual identity, that consistent look, and also making sure the action flows smoothly across all these different viewpoints. It sounds really complicated to get an AI to like understand all of that. What are some of the ways researchers have tried to tackle this before, and where do those approaches typically fall short?
Well, there's been a couple of main approaches. One of them is called appearance conditioned generation. Basically, the idea is you give the AI some specific visual information, like maybe an image of the main character or the setting, and you use that as a guide to, make the AI generate subsequent shots that kind of look similar. The problem is the research shows this method often struggles with like more abstract elements. Things like subtle changes in lighting, overall color tone, those finer details. It's really reliant on what you explicitly tell it. And if something's not a clear visual condition, the AI can easily go off track. Plus, these methods often need like really carefully prepared data sets with super specific conditioning information.
Right? So it's like you have to spell out every single detail beforehand, which is like not always practical. You not always predict everything.
Exactly.
Okay, so what's the other big approach then?
So the other one you see a lot is keyframe generation followed by image to video synthesis. So what they do is they first create a bunch of static images, kind of like key moments in the scene. And these keyframes, they're supposed to be visually consistent with each other. Then they use a separate AI model that takes each keyframe and animates it to create the individual video shots. But the issue here is that even though you have those consistent keyframes, there's no guarantee that the movement of the timing will be consistent across the whole scene. Like the action might not flow smoothly from shot to shot, or the AI might miss important details that happen between those keyframes. Like imagine a character subtly changing their expression between two keyframes. An AI might not pick up on that smooth transition.
Right, so it's like you have these visually similar snapshots, but you lose that dynamic link, that continuous movement, the things that really make a scene feel alive.
Yeah, exactly. It's like those subtle details get lost in the process.
Okay, so we've seen where things get tricky. Now let's get to the good stuff, long context tuning. What is it about this approach that allows it to, potentially overcome these hurdles that we've been talking about?
Well, the cool thing about LCT is it doesn't start from scratch. It actually builds on all the progress we've made with pre-trained single-shot video diffusion models. You know, those models that are already really good are generating those realistic short videos.
Right.
So what LCT does, it essentially expands the context window that these models can process. Instead of just looking at a single shot in isolation, LCT allows the AI to consider all the shots in a whole scene at the same time. And this is huge because it lets the model learn those intricate patterns of cross-shot consistency directly from real scene-level data.
So it's like shifting the AI's focus from creating isolated clips to actually understanding and generating a sequence of connected moments. That's a big difference.
It is. It is.
Okay, so how does it actually do that? How does it expand its understanding? The paper talks about three key innovations in the architecture. Let's start with the first one. Expanded full attention. What's going on there, technically speaking?
So, in a typical video diffusion model based on transformers, you have this thing called an attention mechanism. And it's basically what lets different parts of the input, like the text prompt and the visual features of the video, interact and influence each other. What LCT does is it adapts this full attention mechanism so that it's not just working on a single shot anymore. Instead, it applies it across all the shots in the entire scene. So you're basically taking all the text that describes the scene, all the visual information from every single frame, and you're processing it all together through this one big attention mechanism.
So it's like taking all the descriptive and visual information and throwing it into one giant pot so the AI can see how everything connects, right?
Right.
But if you're just mixing all these different pieces of information together, how does the AI keep track of like which piece belongs to which shot and where he is within that shot? It seems like it could get really confusing.
That's where the second innovation comes in. Interleaved 3D rotary positional embedding, or ROPE. It's a mouthful, I know.
Yeah,
But basically, positional embeddings, they're like these tags that tell the AI, okay, this piece of information is the 10th frame of the third shot. It needs to know both where something is within a shot and which shot it belongs to in the overall scene.
right, like a coordinate system for the video.
Exactly. And LCT's solution is this super clever interleaved 3D rope. For the text prompts, they start with a kind of simplified version of this 3D rope, which is
But I
also
should just
used
go
when they're
on
first
with it.
fine-tuning the single shot
See him
generation.
again.
But when it comes to multi-shot scenes, they do this cool thing. They keep the relative position of the text and video tokens within each shot, but then they interleave these self-contained text video groups that represent each shot. It's almost like arranging these blocks of text and video, one after the other. And each block gets assigned a unique identifier, kind of like a depth or a layer, that corresponds to its shot number. So it's like this 3D structure, it lets the AI tell apart the tokens from different shots based on this absolute shot position. But within each block, the rope keeps those relationships, the timing, the textual connections all intact for that specific shot.
So it's like giving each shot its own space while also preserving its internal structure.
Yeah, that's a great way to put it.
Now, what about the global prompts, the one that describe the whole scene, like the characters, the setting, the overall story? How do those fit into all of this?
Oh, that's a good question. So for global prompts, they use these special dummy video tokens. They're like placeholders that carry that global textual information. And since they're part of the whole sequence that's being processed by the expanded full attention, it means that the global context can influence the generation of all the individual shots.
So it's like these dummy tokens make sure the AI keeps the big picture in mind while generating the individual pieces.
Yeah, exactly. They kind of act as anchors for the overall narrative.
Okay, so we have this this expanded attention mechanism looking at everything in this clever 3D rope system keeping everything organized. What's the third big architectural innovation that helps LCT do its thing?
The third one is asynchronous training time steps. Now, when we talk about diffusion models, a time step basically refers to the amount of noise that's added to the data during training. And typically, you'd add the same level of noise to everything at the same time. But LCT does something different. It applies independent time steps to each shot within a scene during training.
So instead of adding the same amount of noise to everything, you're adding different amounts of noise to different parts of the scene. Why would you do that?
That's the brilliant part. By using these independent time steps, you create dynamic relationships between the different shots. Like shots that are trained with less noise, they retain more of the original visual information, so they can act as a kind of guiding force for the other shots that have more noise. It encourages the model to learn how the different shots relate to each other and how to maintain consistency across them. Like imagine one shot shows a specific object really clearly. That clear image can then help the AI reconstruct the same object in another shot where it might be more obscured or blurry.
It's like having some high definition reference points to help fill in the gaps in the low resolution parts. That's really cool. And the paper mentioned something about using some shot as visual conditions by setting their noise really low. How does that work with this asynchronous time step thing?
Right. So because LCT gives you such fine-grained control over the noise levels for each shot, you can basically say, okay, this shot, I want it to be super clear, almost like a visual guide. And then the AI can use that clear shot to help generate the other shots in the scene. It's a really clever way to combine visual conditioning with the whole diffusion process.
So it's like you're sneaking in those visual cues without having to explicitly tell the AI what to do. That's super elegant. Now, the paper also talks about this thing called context-causal attention for efficiency. What's that all about?
So after the initial LCT training, where every piece of information can connect to every other piece, the model can be fine-tuned further using this context-causal attention. It's a bit more restrictive, kind of like putting some blinders on the AI. Within a single shot, everything can still interact freely. But when the AI is looking at different shots, it can only see the shots that come before it, not the ones that come after.
So it's like the AI can look back in time, but not forward in time?
Exactly. It can learn from the past but not predict the future. And this might seem limiting, but it actually makes the whole process much more efficient.
In what way?
Well, it allows the AI to use a technique called KV caching. It's a bit technical, but basically it means the AI can remember and reuse information from those earlier shots, so it doesn't have to keep recalculating everything from scratch. This speeds up the video generation process significantly, which is really important for practical applications. Nobody wants to wait forever for the AI to generate a video.
Efficiency is always a good thing. Now, let's talk about the data that was used to train this whole model. What kind of data are we talking about here, and what was the training process like?
So they used a really interesting two-tiered system for the prompts. They had global prompts that described the whole scene, the characters, the setting, the main storyline. And then they had per-shot prompts that detailed what was happening in each individual shot. And a really important detail here is that they used unique identifiers for the characters in these per-shot prompts. Like instead of saying the man, they would say character A or something like that. And this is really important because it helps the AI learn to consistently represent those characters across all the different shots.
Makes sense. So it's like giving each character a unique label so the AI doesn't get them mixed up.
Exactly.
Okay, so where did they get all this data, and how did they label it all?
They actually collected a ton of scene-level videos from all sorts of public sources, like movies and documentaries. They broke down these videos into individual scenes and then further into individual shots. And to create all those descriptions, they used this amazing large language model called Gemini 1.5. It's a multimodal model, so it can understand both text and images. And they used it to generate both the global descriptions and the detailed shot-level descriptions. The end result was this huge data set of around 500,000 scenes, each with an average of 5 shots.
That's a massive amount of data. But the paper also mentioned that they included some single-shot videos with temporal variations. Like, what's the point of that?
Right. So that's a really interesting part. To help the model learn smooth transitions and how things change over time, they also included these longer single shot videos that showed some kind of evolution or change within the shot. They basically treated these longer shots as mini multi-shot sequences where the different parts of the shot kind of flow into each other seamlessly. This added another million samples to their data fit. And for the actual multi-shot videos, they did something really clever. They added this special token, shot U, to the prompt right before each new shot description.
So they're basically teaching the AI to recognize those hard cuts between shots.
Exactly. They're explicitly marking the boundaries between shots. It's like saying, hey, pay attention, something's changing here.
That's really smart. Okay, so how do they put all of this data together for training?
They did this thing called joint training, where they trained the model on both the single shot and the multi-shot data at the same time. This way, the AI can keep its ability to generate those cool single shot videos while also learning how to handle those multi-shot sequences. And remember those asynchronous time steps we talked about? Well, they applied that during training too. They randomly assigned different noise levels to different shots within each scene. This creates all sorts of interesting dynamics during the learning process, helping the AI learn those connections between shots more effectively.
So it's a very thorough, thoughtfully designed training process. They're really trying to cover up the bases. Now let's get to the really exciting stuff, the results. The paper talks about these emerging capabilities that LCT unlocks. And the first one is conditional and compositional generation, and it's described as zero shot. What does that even mean? It sounds really impressive.
It is impressive. This is one of those surprising things that emerged from this research. Even though the model wasn't specifically trained to do this, after LCT, it can actually generate new videos by combining different elements in a way it's never seen before. It's like you can give it an image of a specific character and an image of a specific environment, and the AI can put those together and create a whole new scene with that character in that environment.
Wow, that's amazing. It's like giving the AI building blocks and it just intuitively knows how to assemble them into something new. How does it do that without any specific training data for those combinations?
The researchers think it's because of the way LCT trains the AI to understand those scene level relationships. Like in all that training data, the AI has seen tons of examples of establishing shots, close ups, characters interacting with their environment, all these different scenarios. And it's learned these common patterns, these basic rules of how scenes are structured. So even when you give it completely new elements, it can kind of extrapolate from what it's learned and create something coherent.
So it's like it's learned the grammar of visual storytelling. It knows how to put the pieces together in a way that makes sense.
Yeah, that's a great analogy.
Okay, what's the next cool capability they found?
Well, another interesting one is single shot extension. And remember how LCT builds on those single shot video models? Well, it turns out it can also use that ability to extend single shots into much longer videos. Like if you have a short clip, you can use LCT to continue that clip, seamlessly adding more content while keeping the visuals consistent. The researchers were able to generate 10-second videos this way, which is pretty impressive.
So it's like taking a short video and then having the AI imagine what happens next, but in a way that looks totally natural and realistic. That can be super useful for all sorts of things. Okay, what else? What's this interactive generation thing?
So, interactive generation is all about giving creators more control and flexibility. Because LCT can generate these multi-shot sequences, you can actually use it in a much more iterative way. Instead of planning out the entire video beforehand, you can generate one shot at a time, see how it looks, and then decide what you want to do next. It's like a back and forth between the human creator and the AI. You can experiment with different camera angles, different character actions, and the AI can adapt and generate the next shot based on your choices.
That sounds incredibly powerful. It's like having an AI co-director that can help you explore different creative possibilities in real time. It can really democratize video creation, make it much more accessible to people without all the fancy equipment and technical expertise.
Yeah, absolutely. It could be a game changer.
Okay, and the final capability they mentioned was multi-shot generation with human selection. What's the idea behind that?
Right. So this one gets a little more into the nuances of filmmaking. Sometimes the way shots connect in a scene isn't strictly linear. Like a later shot might reference something that happened much earlier in the scene. And if the AI is just focusing on the most recent shot, it might lose track of those earlier details. It's like it has a short-term memory.
So it might not remember how a character looked in an earlier shot if it's only paying attention to what just happened.
Exactly. So to address this, LCT can actually maintain a kind of memory bank of key shots from the scene. And when it's generating a new shot, it can look back at this memory bank and select the most relevant shots to use as references. This helps to maintain consistency across the entire scene and avoid those little errors that can creep in when the AI is just working sequentially.
That's incredibly smart. It's like giving the AI a long-term memory for this scene. Okay, so taking all of this into account, what would you say is the most impactful thing about LCT? What makes it so significant?
Well, I think one of the most impressive things is that LCT achieves all of this without adding any new parameters to the model. It's purely a training innovation, and it shows that with the right approach, we can unlock these really powerful capabilities in existing AI models. And for future research, I think the most exciting possibility is combining LCT with those large multimodal language models, the MLLMs. Imagine having an AI that can understand both language and visuals and use that understanding to generate entire scenes based on a story or a script. That's incredibly powerful.
Yeah, that would be a game changer. It'd be like having an AI screenwriter and director all in one. What other future directions did they mention in the paper?
They also talked about this idea of token dynamic routing. Basically, it's about making the attention mechanism even smarter, so it can selectively focus on the most important information from the past without getting bogged down by irrelevant details. It's all about making the AI more efficient and effective at handling that long-range context.
So it's like refining the AI's memory and attention span, so to speak.
Exactly.
Okay, so let's sum it all up. What's the big takeaway message here? What makes long context tuning so groundbreaking?
I'd say the biggest innovation is that LCT takes these existing single-shot video models and teaches them to understand and generate entire scenes, all while maintaining that visual and temporal coherence. And it does this through these really clever architectural changes, like the expanded attention, the 3D rope for positional encoding, and the asynchronous training time steps. And what's even more amazing is that it unlocks all these cool capabilities like zero-shot compositional generation and interactive editing without needing any specific training for those tasks.
So it's not just about making longer videos. It's about teaching these AI models to think like filmmakers, to understand how scenes are structured and how to tell a visual story. That's huge. And on that note, here's a thought-provoking question for everyone listening. How do you think this kind of technology could change the way we create videos? Could it lead to a more collaborative and iterative approach where human creativity and AI generation work hand in hand? Think about the impact it could have on filmmaking, education, even the way we communicate with each other visually in our everyday lives.
That's a really great question, and it's something we should all be thinking about as this technology continues to develop.
Absolutely. And if you want to dive deeper into the technical details and see some more examples of what LCT can do, definitely check out the original research paper. It's a fascinating read.
Yeah, it's worth a look.
Okay, so that's long context tuning, a big leap forward in video generation and a glimpse into the future of AI-powered storytelling. Thanks for joining us for this deep dive.